Hello students, in this video we shall learn about viscosity. What is viscosity and what is a viscous fluid? Viscosity in simple terms is nothing but liquid friction. Let me put it in simple terms for you. It is nothing but liquid friction. You know that when two bodies are moving over each other, when they are in contact with each other, for example, I got this palm here and let me take the other palm, and when I move it over this, when they are in contact, frictional force arises. Frictional force is the force which opposes motion, right? It slows down the speed of the body. So that is basically friction. Now in liquid, there is a friction. Why? Because you know that from very young age, we will be drawing liquid. For example, when I take a vessel, right, beaker or whatever it is, you draw the surface like this, okay, and just one second please, okay, we draw the surface and then we always draw lines like this. Now why should we draw lines like this? We will be drawing, this is nothing but picturization or visualizing the liquid made up of layers. The liquid is made up of layers, right? So these are the layers you are going to have. Now I am moving to hydrodynamics. Hydrodynamics. The liquid is going to move. That means it is not static. That means I apply the force, there is a tangential force. A force is applied, tangential force, and that force will move the liquid. A simple thing. If I take a layer of air here, water here, I am applying a force. And for example, you can take in a swimming pool, or for example, even in a plate, you take in a hollow plate like that and take water and you will find that it will be moving, right? The layers are in motion. So we are coming into hydrodynamics, right? From hydrostatics we move to hydrodynamics. The first concept is viscosity. So we are assuming to be made up of layers, right? Now I remove this part of it and I am going to draw a fixed surface. Keep this in mind, right? That is a tangential force. Okay, so this is the fixed surface I have got. I got a fixed surface. You can take a plate, okay? This is the fixed surface. And I make a liquid, right? And I'll draw it like layers, right? Like layers. Like these layers, okay? Now, when I apply a force, right? And this layer will move. Let us say the first layer will move. Yes, let me say from here, let me start it. Okay, the first layer is moving. Now, when this is moving, the next layer also will move. But it will move little slower. And what about this layer? This layer also will move like this, right? And then you come to this layer also will move. But the liquid at the bottom, this will be at rest, or velocity at the bottom is 0 and velocity here is maximum. It is maximum. Remember again, what I am discussing here is liquid friction. When you talk about liquid friction, there should be motion. And that motion is due to the tangential force acting. And this tangential force is acting when this layer is moving. What will happen to the lower layer? The lower layer and this layer, what will happen? This will try to reduce the speed of the upper layer. Okay, this will be lesser than that. And compare this layer with this layer. There is a force attracting between that. Okay, there is a force is acting in opposite direction. Frictional force will act in the opposite direction, or the viscous force is acting in the opposite direction. So this layer reduces the speed of this, and this layer reduces the speed of this. The bottommost layer is totally at rest, no velocity. But as the layer goes up and up and up and up, between the layers there is a friction, and that friction is called viscosity. And between these layers, the force, the tangential force is acting, and so the frictional force which is in the opposite direction is also a tangential force. There should be tangent. It is not perpendicular or acting at a particular angle. It is going to be tangent to the surface. Okay, so I understand. So very simple everyday life, let us take. You have glycerine or you have castor oil. You take glycerine and just apply in your hand like this. You'll find it is a little bit thick. It is not just a density, it is viscosity also. You take, for example, water, pour the water, how it is flowing, right? Take oil, right? Maybe you can take vegetable oil or any oil. You take the oil and you pour it, right? And it will be more thick. And you take, for example, castor oil. Castor oil is very heavy, right? And that means very heavy means it has highly viscous, okay? And it will be pour it. It will be more thick, like more like a solid it will be, right? Now viscosity goes on increasing. That means I take a beaker of some oil and I place a spoon, something like that, spoon, and I stir it like this, and I leave it. You'll find that as I move it, there will be a force acting, and the layers are getting disturbed, and slowly they will form concentric circles, and concentric circles will slow down and stop, right? And the layers between them, there is a friction is acting, and that friction, the liquid friction, is called viscosity. I hope you get a generalized idea of viscosity. For example, like in cars and bikes, mobile oil you are putting, that is also a viscous liquid, right? Between the parts of the moving parts of the body, between the machine, you find lubrication is needed, and that is why you call that as a lubricants. Lubricants are substances which reduces friction, right? There are moving parts, and it has to reduce the friction, and that is why we use lubricants in the bikes and the cars. Now our next discussion is going to be how to study this viscosity in terms of mathematical idea. So let me just begin with a concept called coefficient of viscosity. Our next discussion is coefficient of viscosity. Right. Coefficient of viscosity. Now what is this coefficient of viscosity? It's a constant. Now let me take first a fixed layer at the bottom, and let us assume a layer here like this. Let us assume one layer like this. Let us say this layer is P. Let us assume another layer of liquid, okay, and let us say this layer is Q, and this is moving with a velocity V, and this is moving with a velocity greater than this velocity, the uppermost layer where the tangential force is applied, right, V plus dV, okay. And from the fixed surface at the bottom, okay, where the velocity is equal to 0, let us say at this distance is x, we will say, and from here to here this distance is x plus dx, we will say, okay. A small distance between these two layers P and Q, and that is dx, and x plus dx is total distance from the bottom surface. We know that this is the tangential force, and we know that frictional force is going to act in the opposite direction, so that the speed is more. maybe it's around 3 meter per second. Okay, the lower one will be 2 meter per second, and next layer will be 1 meter per second, and it is 0 meter per second, right? The speed goes on decreasing because each layer is trying to slow down. The acceleration is taking place and it is trying to slow down, so it retards it and the speed goes on decreasing. And bottom you'll find, that's why you find that in sea and all, the total bottom will be very calm. The upper one will be too much of movements will be there, wind movement, and waves will be moving. You don't see waves at the bottom because it is very calm, right? I'll compare it with our mind. If you go deep into your mind, if you are in a meditative state, your mind will be calm. Why they say do meditation? Mind will be calm. But in the upper surface, there is anxiety, worry, stress. Lot of thoughts are coming, positive, negative, good, bad, and that is like that. We need to calm down, and that process is called, done it through meditation or prayer or whatever you like, listening to music or dancing or anything which you like it, or playing. That will calm you down and you can be more effective, right? Away from that part, right? Let me come to here. I wanted to find a formula for the force of viscosity, which is a tangential force. I'll say that the force is directly proportional to, let us say the area of these layers we are taking, the area is A, right? The area, each one is same area we are taking, so it is proportional to area. Equation number 1. Second, on what factors is the force of viscosity, viscous force depends on? It also depends on rate of change of velocity with respect to distance. See, this is dv upon dx. Change of velocity with respect to, let me not use the word rate. Rate refers to time. Change of velocity with respect to change in distance between the layer, and that is called velocity gradient, right? This dv upon dx, we call it as velocity gradient. Okay, gradient means different levels, right? Velocity gradient. So the viscous force is directly proportional to area of the layer and is also directly proportional to change of velocity with respect to distance or velocity gradient. Call this as equation number 2. Now let us combine these two. F is proportional to A dv by dx. Okay, or F is equal to, now we need to introduce a constant, and that constant is eta. See, n is there, you extend the n like this, and this is called coefficient of viscosity. Eta is nothing but coefficient of viscosity. Eta A dv by dx, right? And I bring a negative sign here. Why there is a negative sign? Because frictional force is opposite to the external force. So the viscous force or the viscosity is opposite to the externally applied force. So there is a negative sign. It slows down the speed between the layers. We have assumed the liquid is in the form of layers, and we have taken area of the layers, and we have explained this now. Okay, now what is the unit of it? We can conclude this whole discussion by just coming into the unit of it. It's very simple. Okay, we know that F is equal to minus eta A dv by dx. Okay, when you do the negative sign, you can leave it, only modulus you can take. Eta is equal to F. F is here, and this is going to come down A, and this is going to come down dv by dx goes up dx. So that is equal to, force is what? Newton, and the distance is what? Meter divided by area, meter square, velocity, meter per second. Okay, so cancel meter, meter, okay, and you get Newton, meter power minus 2 second, right? So this is the unit. Once again, let me cross check it also with my reference to that, right? Newton second per meter square, right? This can be. This is called Poiseuille, Poise, Poiseuille. Poiseuille is a scientist actually who did the flow of liquid, rate of flow of liquid through the tubes, thin tubes, capillary tube, which I will teach you in the next discussion. We will do it, Poiseuille's formula, and the SI unit is Poiseuille. Okay, and also you can use poise. Poise is actually CGS unit, that is in dyne and centimeter. Poise, because the distances will not be in meter, usually in small layers, distance centimeter, so dyne will be used. So poise is the CGS unit and Poiseuille is the SI unit. So with this idea, I hope that you understand the concept, and from this we also can calculate, find the dimensional formula. ml t power minus 2, second is time, meter power minus 2, L power minus 2. Okay, so L, M, L, 1L, L power minus 1, okay, plus 1, minus 1, minus 2, minus 1, T power minus 1. So this is the dimensional formula. M, L power minus 1, T power minus 1 is the dimensional formula of the coefficient of viscosity. Dear students, I hope you understand. Again, as I said to you, I have made notes, and I also want you, for example, I have made 3 pages notes on only this topic. Fine. Yes, viscosity, right? It's the internal force, different layers. There's a backward drag or viscous drag, you call it, in the tangent. So this is the whole of thing. Dear students, use any book. This is a very precious time. Kindly continue your online studies. That's my only request. Do not waste time. Time is precious. Thank you so much.